The first thing I'm going to do is draw a free body diagram of the sled. We have the normal force going straight up, our mg going straight down. We have our frictional force going opposite, which is to the left, and we have our force applied going at an angle of 15 from the horizontal in this direction. So I'm going to use this triangle right here to figure out our components of our x and our y. So we know that our fx, which would be right here, is 50 cosine of 15, and our fy is 50 sine of 15. So next I'm going to find the equations for Newton's second law in the x and y direction. So our horizontal, which will be our x, is going to be f cosine of theta minus mu times the normal force equals mass times acceleration. And then in our vertical, which is our y direction, there's no movement, so we know that it's going to be 0. For the next part, we're going to find the force of friction on the grass. So we use the force of friction equals mu times Fn. And we have to find our normal force, which is going to be equal to our 10, which is our mass, times our gravity, which is 9.8, plus our Fy, which is 50 sine of 15. So we know that our normal force is 110.9 newtons. We multiply that by our mu of our grass, which is 0.4, and it gives us a force of friction of 44.3 newtons applied on the sled while in the grass. For the next part, we're going to find the acceleration of the sled on the grass. So we use our Newton's second law formula, which we have figured out up here, which is 50 cosine of 15 minus our mu of 0.4 times our normal force, which is 110.9, equals our mass is 10, and we're going to solve for our A. So that gives us an acceleration of 0.39 meters per second squared acceleration on the sled while going over the grass. For the last part, we're going to find the acceleration of the sled when it hits the ice. So we're going to use the same formula, 50 cosine of 15 minus our mu, but for this it's going to be our mu over ice, which is 0.05, times our normal force, which is 110.9, equals 10 for our mass, and we're solving for our acceleration. So that gives us an acceleration when the sled hits the ice of 4.27 meters per second squared. So this tells us that since the coefficient of friction is smaller for the ice, the force of friction is much less, and the sled becomes easier to push and thus experiences a greater acceleration with the same applied force.